Hello, everybody. We're going to be going over some stats and probability today. I wanted to make sure that we go over this, but no, if you don't know everything, if you don't understand everything, that's okay. There's probably going to be about one or two problems on the CAASPP dealing with this. So we're just going to do a quick review. For the first thing is we want to make sure on a notebook, we want to make sure we get the sample definition. And our sample definition is a smaller, manageable version of a larger group. So that's what a sample refers to. Smaller, I don't like that. Our mouse should be classic. So, smaller version of a large group. And it should be an accurate depiction. So it should be accurate. So a principal wants to know if students at the high school are in favor of a new dress code at their school. The principal is not able to ask everybody, so we need an appropriate sample of how this is going to be done. So which sample of students should the principal choose? Which is going to give us the best, most accurate result? All right, so students randomly selected from a list of all the students from the school. Honestly, if everyone's included and everyone is there and you pick randomly, that's probably going to give you a good indication. So all random is a good indication because you're selecting from a whole pool. So that's the large version, everyone, and choose randomly. Students sitting at randomly selected tables. Well, the thing is that you're not including everybody, especially if it's in the library. So if you're in the library, what type of students are in the library? So you got to think, is everyone going to be in the library? No, just a select few. So that's probably not going to be a good choice. Students she selects from the hallway between classes. Well, then again, think about it. What about students that are absent? They don't have the opportunity. What about students that aren't in a certain building or a certain hallway? Not everyone is included. So that's not a good idea to get a sample size of the large group. And students selected by teachers. Well, you kind of include everyone, but then again, students selected by teachers are probably going to favor one maybe over the other. So it's not going to be completely random unless they all spin a wheel or something like that, like I do. So the best answer would most likely be A and not B, C, or D. Let's go to another example. David wants to estimate the number of students from his 7th grade class whose favorite subject is math. Estimate the number of students from 7th grade whose favorite subject is math. So he plans to ask 20 students and wants the best chance that it will be representative of this 7th grade class. So 7th grade, so we want 7th grade, let's do green. 7th grade and math. From which of the population should he randomly select? So random. Students in math class? I guess students in math class, but if they're in math class, they're probably going to maybe favor math class. So that's the only thing that's really random. Students on a school bus? Not everyone is really on a school bus. Some drive or some walk or some take bikes. So I don't think math class is a good indicator because it's not completely random. I don't think school bus. Students in a 7th grade assembly, I think that one might be good because they're all students, all 7th grade in an assembly that you can choose from. Students in cafeteria. Well, this could be 6th graders, this can be 7th graders, and this can be 8th graders. So my best guess is going to be C. So that's going to be including everyone in this situation. And C is the correct answer for this one because students in the 7th grade, it's all 7th grade, it's everybody, and it's random. Now, yes, maybe some people are absent, but it's not as specific as the other ones. All right, moving down to SP.7. A random sample of 50 students from a high school with 100 students surveyed. Okay, so there's a lot of things here. So we have 50 students with 1,000 total. Each asked what science class he or she is taking and all students that take science. So this table shows below. Okay, so that means all of this should equal 50 students. Based on the survey results, which statement about all of the students at the high school is most appropriate to take? So we are basing this result on all of the students and kind of like what's best for this student. So here's the results out of 50 students. So that means for physics, we have 6 out of 50. For chemistry, we have 10 out of 50. For biology, we have 18 out of 50. For earth, we have 4 out of 50. And then for health, we have 12 out of 50. So twice as many students at the high school are taking biology than taking chemistry. So which statements about all of the students is most appropriate to take? So what is most appropriate? What is the best example? Twice as many students taking biology than chemistry. Well, here's biology and here's chemistry. That would be 20. So I don't think that's true. It's not true, but it's close. So maybe about 10% of students at the high school, 10% of the students are taking chemistry. Where's chemistry? So this is 10 out of 50, but that's not 10%. This right here is 20%. So that's not actually a good one to take either. In a group of 25 students at the high school, it is expected that 4 are taking earth science. So they changed it from 50 to 25. So is 4 out of 25 the same thing as 4 out of 50? It isn't. They changed it to 25, so it can't be C. So A is the best answer so far. It is estimated that about 120 students at the high school are taking physics. So let's go to physics. Physics is 6 out of 50. That's 12 out of 100. So that means that would be 120 out of 1,000. So if I times this by 2, times this by 10, yeah, 120 out of that. So the answer is going to be D, because if you multiply this by 2, you get 12 100ths. And then if you multiply this by 10, you get 120 over 1,000. So that makes the most sense. So let's take a look. Yep, it is D. So D is the correct answer for this example here. All right, moving on to the next one. We're going to keep going. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions. It's a lot, but we're going to go through them rather quickly. All right. So we have the next one is sandwich shop. Manager, estimate how many of each sandwich will be purchased in a month. Okay. So let's take a look at our sandwiches here. These are all the orders in 1 week. So I don't want to use a rectangle. I want to use a pen. So this is all for 1 week. So these are the totals. And it says, based on the data, which estimate represents the number of types of sandwiches likely to be ordered in a month? So in a month, so 4 weeks in a month. So if I were to times this by 4, you would get a specific answer. So this would be about 304. The middle one for turkey would be about 322. And so that's tuna. And turkey is, sorry, I'm saying it by 4. This is completely wrong. Let me try that one more time. I apologize. Times 4. I did it times by 3. I don't know why. So that's going to be 150, 300, 600, 608. This one should be about 4, 12, 16, 456. And this one's going to be 90%, 36, 3, and 436. So now these are the exacts, but what is the best estimates in a month? So 850 and 608. No, that's not right. How about 650? Okay, 650 can work. What about 490? Yeah, 490 will work. 900 turkey? Wow, I was wrong. That's 836. I put 436. It's 836. 900 turkey could be the answer. Make sure you edit that. I'm sorry about that. That could be it. It could be B. B's the best guess so far. 480? No, not 480. And 1300? No. So all you really need to know is B. B is going to be the best bet. And let's take a look. And B is the correct answer. Yeah. So I don't know why I couldn't do math today. Math is terrible. That's all right. We're going to scroll down here. Let's clear the selection. Okay. These are box plots, something that I really haven't talked to you about. So let's put this in your notebook. So we're going to put this in our notebook. Let's go ahead and clear that. Let's erase this. Move that. Clear. Okay. And what we're going to do is we are going to talk about what is each thing. So this right here is the minimum. This right here is the maximum. This right here, that is our mean, I believe. Let's do the box box plot. There we go. Oh, it's the median. So take a look at this. So our middle is our median. Our bottom is our minimum. Our top is our maximum. And then we have the interquartile range. So median, interquartile 1, interquartile 3, and this is the IQR, interquartile range. IQR is everything in between here. That's the basics. So in each class, at least 25% of the students scored below 80. So 25% of the students below 80, I would say that is, because here's 25, here's another 25, here's another 25, and here's another 25. So here is all our 25 quartiles. So at least 25 scored below. Yes, that is correct. It should be true because this is the interquartile right here. And so 25% did score below 80. So true. The median test score of Class B is 5 points less than the median of Class A. So here's median Class B, and here's the median of Class A. Is 5 points less than median test score Class A? That's false. In each class, more than 25% of students have scored greater than 90. So here's the marker above 25%, 25%. Above 90, yes. Both have scored above 90. So we take a look over here. It is true, false, true. So again, if you have these notes over here, so this is each section is like a piece of the 25, 25, 25, 25, 25. And then this is the middle number. The median is the middle. Then you know what to do. Moving on to the next one. All right. I think you've seen this before. So we have a bag of marbles. Yay. We have 5 blue, 9 yellow, 2 red. Let me try that again. Let me change my... So 5 blue, 9 yellow, 2 red. So 5 plus 9 plus 2. That gives us a total of 16 total. So 5 out of 16 for blue, 9 out of 16 for yellow, 2 out of 16 for red. So make sure you know what your totals are. One marble is selected at random. Determine whether the statement is correct of the likelihood. Is it likely or not? It is impossible a green marble will be selected. Are there any green marbles? No. So is it impossible? Yes, it is impossible. There will be no green marbles. It is unlikely that a yellow marble will be selected. Yellow is actually the highest one. So it is not unlikely. It is most likely going to be a yellow more than red or blue. It is certain that a blue marble, remember, so impossible. Let's put it over here actually. Um, it is, let's go ahead and move this up for stats. Impossible is 0% chance. Certain is 100% chance. So that's what we have there. So is it, for example, is it possible or certain? All right, so is it certain a blue marble will be selected? It is not certain. So false. It is unlikely that a red marble will be selected. Yeah, unlikely is here. 2 out of 16, definitely unlikely. And so if we take a look here, true, false, false, true, and that's what we have here. All right, gonna go through this really quickly. A deck of cards, a deck of 12 cards labeled 1 through 12 is shuffled. One card is randomly selected. Determine whether each statement is correctly on the likelihood. Is it likely or not? It is impossible that a card with a number 13, greater than 13 is selected. That is true, obviously, because it's 1 through 12. It is likely that a card with a number greater than 2 is selected. Yes, because 1, 2, 3, 4, all the way to 12, greater than 2 is 3 through 12. It's very likely. It is certain that a card with an odd or even number is selected. Yes, it's either odd or even. There's nothing else. It's certain. It's a 100% chance of that. It is unlikely that a card with a number less than 7 is selected. So let's go ahead and write this out. 4, 5, 6. And that's the cards that we want to choose. 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's even. Is it unlikely that a card with a number less than 7 is selected? I think that should be false. It's actually even. It should be equally split. So, yep, true, true, false. That is the exact answer for that next question. All right. Next, we have a spinner. We have spun 20 times. What is the best prediction for the land on an orange section? All right, so we have 3 different outcomes. We have for orange is 30 out of, it looks like 30, 60, 90, 100. And it says, what's the best prediction for if it's spun out of 20 times? Well, so 30 out of 100 is a 30% chance. So what would it be if it was out of 20 spins? So then you just kind of have to work backwards. So this would be divided by 5. This would be divided by 5. 100 spins down to 20 is divided by 5. 30 divided by 5 would be 6. So B would be your answer. And all you have to do is write a simple proportion, and then you'll be able to figure that out. So B is your correct answer. All right, so, oops, there we go. All right, coin is flipped 4 times. It lands facing heads up 3 out of 4 times. The probability of a fair coin landing heads up is 1/2. Select the statement that gives most likely explanation for why it is different than the predicted probability. Well, sometimes you flip a coin and you get heads twice in a row. That's pretty much it. Is the coin of use too heavy? No. The total number of coin flips is small. You only flipped it 4 times, so it's possible to get 1 heads and 3 tails, or vice versa. The coin had heads on both sides. No, because it landed on tails once at least, so it can't be on both sides. The probabilities of 3/4 of 1 have different denominators. I mean, they do have different denominators, but that doesn't mean anything. I would say B. B would be the correct answer for this type of problem. And the correct answer is B. So yeah, You got to flip it more times. The more times you flip it, the better odds you get. All right. Next, the spinner is divided into 8 equal zones. Enter the probability of landing on a section labeled 2 on the first end. So there's 1, 2. So there's 2 out of 8 sections. So it should be, the odds should be 1/4. 0.25, which is correct because that is a quarter. 1/4. The probability is 1/4. All right. Next up, the table shows a randomly selected color marble from the bag 20 times. So here's 20. Based on the results, enter the expected probability of selecting a red marble. So it's 7 out of 20. What's the probability of selecting a red marble? Well, it's 7 out of 20. That is going to be 3.5 out of 10, which is 35%. Or 0.35 as a decimal. Can I scroll over? 0.35. There you go. A fair coin is flipped 3 times. Enter the probability of landing on heads 3 times. So chance to land on head is 1, 2, 3. So that is going to be heads, heads, heads. Or you can just say heads, tails, heads, tails, heads, tails. Has to land on it multiple times. You can do a probability table like this. Heads, tails, heads, tails. So heads, tails. Let me use black. Heads, tails, heads, tails, heads, tails, all the way. So it's 1 out of 8. So 1/8, which is 0.125. No, I'm going really fast because I have a meeting to go to. 0.125. Just know that you can just do 1/2 times 1/2 times 1/2. You can just multiply them if you find the total probability. All right. Same thing here. 2 cubes. So you have a cube and a cube. There's 1 through 6. So 1, 2, 3, 4, 5, 6. And then you have another 6 chances. 1, 2, 3, 4, 5, 6. So instead of doing a tree like this, you can just do 1/6 times 1/6. What's the probability of both number cubes landing on 4? So that means that's 1 in a 6 chance times 1 in 6. So that's 1 out of 36. All right. Looks like that's it. I got to go to a meeting. Thank you all so much for watching the stats. If you have questions, please let me know in class or email me. I got to get going. Talk to you.